In this section, I'm going to demonstrate how to use Python scripting to generate a user-defined scan pattern. This is our final and most advanced example. Two scripts are required: a Python script to create a scan pattern as a scan list, and a DM script to acquire a spectrum image fully programmatically using this scan list. To keep the lesson short, I'm only going to show you the key points at a relatively high level. First of all, we need a Python script containing a Python function that generates a scan list. I'll open my function now, which I've called generatescanlist.py. This Python script must contain a single function which returns a tag list object or saves a tag list file to disk. The tag list contains an indexed list of scan points which will be used by the spectrum imaging code. In the script example here, I'm saving a tag list file to disk. If I execute my script, close the file and go back to my Explorer window, I can see that I have a new file called scanlist.gtg. Let's open the tag list to check the contents. It contains an indexed list of scan coordinates as expected. Now I need to open my spectrum image acquisition script. The script I'm using makes use of the parameter set based spectrum imaging API. A full description of this is really beyond the scope of this lesson, but for anyone who is interested, the API is very well documented in the DM help file. Go to the help menu and select the search menu item. Go to the scripting section, expand the plugin subsection, spectrum image acquisition, and then look at the scripted acquisition parameter sets section. There are lots of really useful examples here and full documentation of this API feature. Let's scroll down in my acquisition script. The important lines that relate to custom scan are located between lines 68 and 74. The tag list file is imported here on line 69, and there are some additional lines below which tell the API to set up the 2D array from this tag list. If I execute the script, the SI acquisition begins and uses this custom NN sequential type scan pattern. And that's it.